Correct answer, of course, is A. 1.6 times 10 to the minus 19th joules in an electron volt. Electron volt is a tiny amount of energy, but it's the amount of energy that's typical for energy levels in atoms, as we'll see. Now, the accelerator I work at, the Large Hadron Collider at CERN, it accelerates protons by repeatedly sending them through a cavity where there's a strong electric field. Okay? And it ultimately reaches, this year, it's going to turn on and reach 8 trillion electron volts. So when those protons go through, it's effectively going through a 1 trillion volt thing. I want to talk about one last concept here, which are equipotentials. We go back to this picture of an arrangement of positive and negative charges. And you'll notice that I didn't talk about, last time we looked at this, these dashed blue lines. So what's going on with those? Well, if you look at the labels, you see 0.5, 0, minus 0.5, minus 1. That's actually the voltage, the electric potential at that point in space. And so lines like this correspond to places where the electric potential is the same. Now, the way you should think about these diagrams is the same way that you think about this. This is a topographic map. And you've probably used one before, or maybe not. There are people who like maps, people don't like maps, people like just directions rather than maps. But okay, if you like maps and you've used a topo map, you know what this means. You can see where the mountains are and where the valleys are on a topographic map by looking at the contour lines. The contour lines tell you your altitude, right? So for example, the peak here looks like this heavy line was 9,600. That means this peak is probably just over 10,000 feet or something like that. It looks like they're every 400 feet. The heavy lines anyway. Yeah, 1, 2, 3, 4, 5. I don't know. Anyway, so that's a peak. And you can see where the contour lines are very close together. What does that mean? It means they have a very steep slope, right? So if you jumped off of there with your skis, you'd go down pretty fast. And you go down to the low point over here, like where the lake is. That's where the water flows to. It's exactly the same. You should use exactly the same set of mental pictures in your head here. Here we have positive charges. Positive charges are like the peaks of a mountain as far as electric potential goes. So the closer and closer you get, the peak gets higher and higher, right? Because 1 over r squared. So if this is 0.5, that's 1. That's 1.5 volts. If you got even closer, 2, you get 2, 2.5, etc. The closer you get, the higher the voltage. In fact, it goes to infinity if you look at the calculation for a point charge. Now, if this is a peak, then the negative charge is a valley. So you should think of that as a depression, or you're going from uphill to downhill. And just as if you had a big rock or something, it would roll from a high peak down following the contours. If you have a positive electric charge here, it gets pushed away from the positive toward the negative by the electric field. But also you could think of it in terms of energy as going from high potential energy to low potential energy. And it would gain kinetic energy as it does so. But that's what we mean by electric potential. And these lines are lines of equal electric potential. Now, we're going to have you do exercises where you draw equipotential lines for different arrangements of charges. And one of the things that you should notice about this is that, for example, as you go from this one to this one, as you cross these equipotential lines, notice the angle at which the equipotential lines cross the electric field lines. It's always 90 degrees, right? Everywhere that you see it. So that's one of the rules. When you draw equipotential lines, they're perpendicular to the electric field lines. And vice versa, if we gave you a bunch of equipotential lines, you should be able to draw the electric field lines. How? By going perpendicularly through the equipotential lines from positive to negative charges. That makes sense, right? Now we could do that. Let's do a simple example of that. Drop out of here. So suppose we have a positive charge here and a negative charge here, and we wanted to draw the equipotential lines. Well, we saw that the electric field lines look sort of like this, right? So we draw those like that, some number coming in, that one going in like that. Whoops, that's wrong. Points away from the positive charge. So what would we do? We'd draw a dashed line like that, maybe another dashed line like that, trying to stay 90 degrees. So you could draw an equipotential that looks like that, another equipotential that looks like that, and so forth. You're going to get practice doing that, either starting from the equipotentials and drawing the electric field lines, or starting from the electric field lines and drawing rough equipotential lines. And you could do that for an arrangement of 3 charges or more. And so there are a lot of fun problems that you can do along those lines.